Hey all, Nick here. In this video, we're going to go ahead and describe what an Ethereum validator is while going through the process of setting one up. So what we're going to do is we're going to run a validator on the Ethereum Gorilla testnet, and we're going to go through and import our validator keys, make our deposit, do everything we need to do to get a validator up and running. So before we dive into that, let me give a little bit of a backstory as to what exactly is a validator and why would we want to run one. So ever since December 2020, the Ethereum network has been running what we call the beacon chain, or ETH2. And the beacon chain is basically a new consensus system for the Ethereum network. I say new relatively lightly, it's now 2023 and it's fully live. But this is a way for us to get off of the proof of work consensus algorithm that we were previously using. So what is a consensus algorithm? A consensus algorithm is basically a way for all of the distributed nodes on the network to agree on a certain state of the network, or what is the correct state of the network. For example, you have a balance in your wallet and the entire network should agree that that is your balance and it should be correct. So that is the idea of consensus, and we reach consensus using various different techniques, and different chains use different algorithms. Today, Ethereum is using what's called proof of stake. Now, proof of stake basically means that users of the network come together, they put up stake, or they put, not stake as in like meat or food, but stake as in funds. They put their own funds up and they lock them up for the right to run a validator. So the validator, when running, has to perform certain duties in a certain fashion. And if they behave in a certain fashion, in the fashion that they should, they're rewarded new ETH. So why would we want to run a validator? Well, for one, we are participating in the security of the network by running a validator, and we're also getting something in return. We are taking our ETH, we're locking it up, and we're earning rewards based on the activity that we're doing on the network. Assuming we're doing good activity, we're going to get rewards. If we behave in a negative fashion, then we will get slashed, or we'll get removed rewards, so our stake will go down. So really, the driver there for us, the incentive for us to become a validator, is really to earn rewards and secure the network. Now, how do we do this? So there's a lot of interesting things that we need to do in order for us to run a validator. Now, we've been posting a lot of content on how to run a Rocketpool node and participate in the Rocketpool protocol, which is definitely related to what we're talking about here, because we're still, at the end of the day, running validators. But in this video, we're going to go ahead and run a solo validator. And a solo validator doesn't use any of the fancy smart contract kind of liquid staking protocols that are all the rage right now. We're just doing a pure Ethereum validator where we deposit 32 ETH into a special contract, and by doing that, we get the right to run a validator. Now, to run a validator, we're going to see in a couple of minutes how to actually go through and do that, and we're going to use a certain technology stack to achieve that, to kind of simplify it to some degree. So there's a couple of steps that we need to go through in order for us to run a validator. For one, we do need to have 32 ETH. Now, definitely fully realize that on the live network, that is a lot of ETH. It's a lot of money. So this is something that is kind of prohibited from a financial perspective for a lot of folks. There are a lot of tools, like this is one of the reasons why we're attracted to Rocketpool, is that Rocketpool doesn't require as much ETH because it uses other techniques to be able to fill that 32 ETH kind of requirement up. But at the protocol level, at the Ethereum level, it does require 32 ETH to be able to run a validator. So we're going to go through how to do that and how to make that deposit. Now, luckily, the Ethereum Foundation has created this website that I'm sitting on right now called Launchpad. And now what Launchpad is going to do, it's going to kind of take us through a wizard that is going to take us step by step through the process of going ahead and getting our validator up and running. Now, there are a couple of core key processes we need to take here, just from a top level. First, we do need to have the 32 ETH. Then we need to create our validator keys. And then we need to craft a special deposit into a deposit contract on the Ethereum 1, or the execution layer of Ethereum. So real briefly about these different layers of Ethereum. There are really two core components here. And we could talk about a third one in a minute, but there's two core components. There's ETH1, or the execution layer, and that's where all of the user activity happens. So this is where we have users with their accounts, we have smart contracts being deployed, we have transactions being had, we have blocks being produced, and this is where all of the user activity happens. That is also where this special smart contract, we call it the beacon chain deposit contract, exists. So we craft a special transaction into that contract. Now that transaction isn't just simply throwing 32 ETH at it. We're actually putting 32 ETH into a contract call, a method call that we're calling into this contract, and that contract has certain parameters that tell it, hey, this 32 ETH is associated with this validator public key. Now that validator public key is really important because that is part of the validator keys that we need to run within our Ethereum software stack to be able to perform those duties so that we can actually earn rewards. So really top level, what we're doing here is we're registering a public key on the execution layer. Once we register that public key, we can now take the public-private key pair, really the private key, and run it within a software stack that we need to maintain and keep up and running that performs certain duties. Now the software is already configured to do those duties. All we need to do is load that private key, those keys, into our software stack and keep those bad boys running. Okay, so that's the process. Now what I'm going to do is I'm going to go through and just go through it as we step through. So I'm going to go through this wizard here. I'm going to say become a validator. Now I'm on the gorelli.launchpad.ethereum.org site, and this is going to take you through a bunch of advisories here. You're going through this for the first time. I recommend you go through this thoroughly. You read these screens thoroughly. This is something that shouldn't be taken lightly. We're talking about a lot of funds here. You should fully understand the risks that are involved with this. This is also not a short-term thing. This is something that you're probably going to want to tie up this ETH for a pretty long period of time. So you want to understand what's going on here. And that's part of the reason why we're creating these videos, is to kind of educate folks and just to take them through that process. So I'm going to go rather quickly through this, but this is basically telling you that, hey, this is what proof of stake is. I realize that I have to deposit 32 ETH. This part is interesting. This is basically saying, hey, you should be pretty comfortable with using a terminal on a computer. And I'm going to dive into the terminal in a minute, but you do want to be somewhat technical to be able to do this stuff. And we are here to help. You know, I'm with Long Island Blockchain, and we do help folks do this. So, you know, we're educating folks, but we're also here to help if you do want a helping hand along the way for you to run your own validators. We're not saying, hey, deposit your money with us and we're going to go ahead and do everything. We want to help you do it. And that's really the kind of power of this decentralized network, is that you can run it. You can do this. So I'm going to say accept there. We do need to keep the server up and running. So this is something, it's not just a flip a switch and you're done. You're going to have to maintain a server. You're going to have to keep it updated. You're going to have to constantly be applying security patches and things like that. We realize that if we don't run the right way, we will get in trouble for it. And getting in trouble means losing our stake, either part of it or all of it, depending on how bad we behave. So the worst thing we can do is take those keys that I just mentioned, those validator keys, and we run them simultaneously on two different software stacks, thinking that we can be clever and get, you know, multiply our rewards. We can't do that. The network will see that we are attesting two different ways, and it's going to slash you. You don't want to do that. This is basically saying, hey, you better keep your keys private. That's important in all aspects of just public key encryption. This is early adopter. This is new stuff, right? This is something, I mean, just the withdrawals just got enabled a few months back, and we're still early days with this. So we're still learning and exploring, and this is another reason why we do these videos. We want to learn with you guys. So it goes through a little checklist, confirm, we're good to go. Okay, so now this goes into a little bit of the software that we need to run. What type of software do we need? So if folks that are watching this are familiar with web development, which I'm a web developer, I set up a lot of different infrastructure and things like that. We typically stand up different pieces of software like web servers and different languages, different plugins to those web servers like PHP or Ruby or whatever. This is kind of similar, but it's a different stack of software. So we need an execution client. This execution client basically is the component that runs all of the execution layer stuff. So in terms of the smart contracts and blocks and things like that, this is the ETH1 chain. This is where the deposit contract exists. In this case, we're going to run the Nethermind client. So it's already selected there. And I'm going to go ahead and continue there. And now we need a consensus client. The consensus client is the piece of software that runs the ETH2 chain or the beacon chain. In this case, we're running Lighthouse. Now, both of these pieces of software talk to each other. They're integrated together. So we're going to go ahead and say we're running Lighthouse, continue. Okay, how many key pairs would we like to run? We're going to go ahead and just run one validator, and that's going to require 32 test ETH. I'm pretty sure I have a test account here that does have what we need inside of it. So let's take a look. Okay, cool. So we have some Gorelli test ETH in this test account, and we can go ahead and use that. Withdrawal address. This is super, super important. So there is a separation of duties here. So we have what's called the validator keys, which we discussed previously. That is the key that's going to perform all of those different duties that enable you to earn rewards. That doesn't mean that those validator keys have access to this 32 ETH that we're depositing. So when we want to exit these validators, when you want to get out and just take your ETH and go home, you need to then withdraw, right? And when you do that withdraw, it's not going to go to the validator keys. The validator doesn't have access to that. It's going to go to a special address called the withdraw address. Now, the withdraw address is part of the deposit. Remember I said we make a special deposit into the beacon chain deposit contract, which is on the execution chain. That call has a couple of parameters. The public key of the validator that we want to register, and the withdrawal address. The withdrawal address is basically the address that has access to that 32 ETH when we do a withdrawal. It's also the address that will be used when periodic skimming happens from rewards that you've earned on the beacon chain. So every couple of days or so right now, I think it's like every 6 days right now, a withdrawal will come out and then go to this address. It's kind of like a trickle of rewards that will keep coming into this address for performing your duties on the beacon chain. So I'm going to go ahead, I'm going to make it this test account here that I have. This is important because you cannot change this. So this is something that it's important you get this right. This is unlike some of the other systems that are built on top of this, like Rocketpool, where we set the withdrawal address to an actual smart contract. And that smart contract allows us to go ahead and change where the funds go to when they come out to that smart contract. The actual deposit, though, still is fixed on this withdrawal address. So a level deeper, at the protocol level here in Ethereum, this is not going to be changed once we set it. That's really, really important. You want to make sure that you have this right. Triple check it. Make sure that you're putting the right address in there. Okay, so we have that there. And now what operating system are we running? We're going to go ahead and say we're running Linux. And now here is an important part. Now we're going to go ahead and we're going to generate the deposit information to be able to actually perform the deposit into the deposit contract. So there's a couple of different ways we can do this. It looks like there's a GUI app you can build from source, and there's a CLI app. I'm going to go ahead and use a CLI app, which is basically a command line interface application. And I'm going to go here and just see the releases we have here. Okay, awesome. All right, so I'm going to run this here. I am connected to a test machine here on our test network, LIBC testnets, and I'm going to use this machine to go ahead and generate these deposits into the chain. So let's go ahead and download this bad boy. So I'm pretty sure, what kind of CPU am I running on this bad boy? Okay, x86-64. So let's go ahead and, not Windows, this one. Okay, so I'm going to go ahead and just get this. We'll go ahead and just extract this. And now we have a nice little tool here called Deposit that we can use. Excellent. That's on our machine. And now what we're going to do here is it gives us a command that we can pass here. So this is going to create a new mnemonic that is going to be the private key, the seed phrase for the private and public key pairs for our validators. In this case, we're going to generate one validator here, and it's going to be on the Gorelli chain, and we're setting the withdrawal address to the withdrawal address we stated above. So really what we could do is we could just go ahead and copy this bad boy. Now this is going to show private information to the screen. This is just test information. So I'm going to exit these validators before I probably post this. But this is information that you do not want to share publicly. So this is going to show information that is private. So I'm going to paste this in here and hit enter. And it's going to take us through a little bit of a process here. Typically what you would do is you would boot this into a secure Linux environment that is not on the internet, and you could do this to ensure that those private keys are never touching anything that's connected. So I'm obviously not doing that here. So when you do this, you want to make sure that you boot into a safe kind of environment here. And I'm going to just go ahead and hit enter. You are setting an ETH1 address as your withdrawal address. Please ensure that you have control of the address. Again, it's just it's making sure that we're doing the right thing here. I'm going to go ahead and copy this again. And actually, I'm going to copy it from MetaMask because it has that nice click to copy. So I'm going to go ahead and do that. Okay. We're going to choose English for a mnemonic list. And it's asking us to set a password to encrypt it. So I'll go ahead and just enter a password here. And okay, so it's going to give us this mnemonic, which this is our seed phrase for our validator keys. And I'm just going to go ahead and throw this on a different screen over here. And once we've written it down, boom. Now it's going to go ahead and ask us to type this back in. So I will go ahead and do that. Okay, once we do that, it's going to go ahead and generate our keys. And it's going to post those keys into this validator keys directory. Awesome. So now if we go here, we go into validator keys. Now we have our different key stores. We have two files here. We have a deposit data.json and a key store /m. Now this is actually going to show you, I won't go into this in this video, but this is going to show you the path it used to derive these keys. I'll probably make a whole video on that topic. Super interesting topic, but this is important if you want to rederive these keys from that seed phrase. If you want to like exit your validators and you don't have access to the server or something, that comes in helpful. So we have these two files. Excellent. Now what we're going to do is shoot off of there. Okay, so now that we have these files here, let's keep going through this. And I have my keys for safekeeping. You're going to want to write down that mnemonic. You want to protect that, and then we're going to continue. Okay. So now this interface is asking us to upload the deposit data file that is located in that directory. So we're going to go ahead and do that. So I actually have this on a remote server. So I think what I'm going to do is just copy this into a new file and then save it and post it to this here. So let's go ahead and okay, so now let's go ahead and take this file, which I now have on my desktop. I'm going to drag it and put it right here, and then we're going to continue. And now here we now have all the information we need to craft this special deposit into the deposit contract. It's going to ask us what wallet we want to use. I'm going to go ahead and use my MetaMask wallet, and we'll go ahead and connect using the test account that we have here. It checks that we're connected to the right network, which we are, and it checks that we have enough in our balance to do what we're looking to do. And it again shows you the withdrawal address is set so we could see kind of what this is. That's looking good. Let's go ahead and continue. Now we're getting close to making this deposit. So let's go ahead and again go through and make sure that we understand all these risks that are involved here. And we're going to go ahead and check the contract address. And this is going to allow us to just verify and understand again these risks, reveal the address, and just take a look at this is the contract on Etherscan. This is the deposit contract. So there's currently a ton of ETH here. There's about 25 million ETH inside of this contract. And you can see that this contract is basically just handling deposits. All right. So this is the contract we're going to interact with through this interface. And I'm going to say, hey, I'm good to go. Good to go. Continue. And now we're ready to make our deposit. So now we have our validator public key, which we just generated using that CLI tool. That was packaged into that deposit.json file along with our withdrawal address. And now we're ready to confirm our deposit and send our ETH to this contract. So we're going to go ahead and send deposit. Now this is going to craft our transaction for us. 32 ETH is going there, and I was having some problems with Gorelli earlier today with just transaction times, and I am going to bump this up because I feel like this is just the gas fees were just insane. Maybe that's a little excessive, but let's go ahead and. Why is that here on that? There we go. Okay, we'll confirm that. Now, on the live network, you shouldn't have to do what I just did with gas. The gas today seems to be all over the map. So I just bumped that up unnecessarily. So, all right, transaction was successful. We should be able to see that the deposit went through. Let's go ahead and just look at the transaction here. All right, gas was actually really cheap, which is good. And good. So we got it in there. Now this should show. Well, I guess it doesn't do it on Gorelli. It will show you the fact that it was a beacon chain deposit. It just may not be picked up. Ah, there we go. So we can look at it on beacon chain. It was picked up on beacon chain. You can see that we do have a deposit. 42 seconds ago, it came through. So now that validator public key that we just registered with the beacon chain now is eventually going to have the right to run in a validator in the software stack that we talked about earlier and be able to actually perform its duties. So I'm actually going to pause the video here while this is processing, and we're going to come back in a little bit, and we're going to go ahead and import those keys into the software stack. So we're going to dive a little bit more into the software stack and how that's all working. We are going to be using the Rocketpool Smartnode setup along with the eth-docker setup. So it's going to be a couple of components here that we're going to integrate together and run so that we can go ahead and run this validator and start to perform our duties. All right, awesome. I will be back. All right, hey guys, a day has passed and we did process our deposits on the testnet. And look at us, we are active already, but we're not active because our validator is not running. So this is a major problem. We are basically going to lose ETH if we keep going in this state or we don't exit this validator. So in this part, what I'd like to do is let's go ahead and get these validator keys all imported into our validator, and let's dive a little bit into the software stack required to be able to run these validators. So what we're going to do is we're going to run our different pieces of software using the Rocketpool Smartnode and the eth-docker validator. And I'm going to go into a little bit of what that is and the different components at play here. So I have a little diagram, really simple diagram I put together here. Now this is basically the core components of an Ethereum validator software stack. You need to really run these three components. Now, of course, there are other pieces here at play. This is a very simplified look at this, kind of like a top level view. But if we look at this, we have two core clients here. We have the consensus client and we have the execution client. Execution client, as I mentioned earlier, is really the ETH1 chain. It's the chain where everyone is doing all of the different activities like DeFi. This is where smart contracts are deployed. This is where our accounts live. Then we have another client, because now we're on proof of stake, called the consensus client. The consensus client is really responsible for it. We call it the beacon chain, and it's responsible for basically finalizing the chain in certain epochs. So there's this the way time works within the ETH2 chain is every about 6.5 minutes, there is a new epoch. An epoch is assigned a number, and within each epoch, there are 32 slots. And within each slot, there has the potential to be a block. Now, typically, we do see a block within each slot. Now, the consensus client randomly selects a validator in each slot to be eligible to propose a block. So a validator client now gets that opportunity to propose a block, and they can go out there and put together a bunch of transactions from the execution side and go ahead and then propose that block to the network. And you gain rewards for that, which is awesome. So a validator client can propose a block, but there's other duties as well, like attesting to slots and things like that. So in each epoch, a validator client is expected to attest to one slot. So you want to run attestations. I'm not going to go crazy deep into exactly what all that is. Maybe we could do a series on that later on. But these are the basic duties that your validator is going to perform, and this is the basic outline of how everything is connected. So we need to run our consensus client and execution client. Now, the consensus client and execution client both have their respected chain databases. These are pretty large databases. So these databases hold all the different state information for each one of these chains. Really, we're talking about two blockchains here that comprise the Ethereum ecosystem. So in order for us to run this, typically at Long Island Blockchain, we do a lot of Rocketpool stuff. So Rocketpool, the Rocketpool community has put together this really great project called Smartnode. And I've gone into Smartnode. I have a whole series on it. We have a whole series in the on the YouTube channel here. And we go into how to set this up. I'm not going to go into installing this. That's kind of already out there. I'll leave some links down below. But this basically packages up all of this software. So really what we have here is Smartnode is going to do this for us. It's going to basically take this entire stack and really package it up all nice for us into Smartnode, which is really convenient and makes it a lot easier to manage. Now Smartnode is basically uses Docker, right? So it uses Docker Compose to be able to create containers. Now Docker is a whole nother topic. It's about containerization and taking software and packaging it in certain ways. Super powerful technology, but it's very useful here because all of these different pieces of software, they are developed by different teams and there's completely different development cycles going on, and we need to be able to stay up to date with these pieces of software as we're running our validator. So using the Smartnode and what the community does, a lot of the Rocketpool team, which is great, keeps us up to date so that we can continuously update our servers and stay up to date. The problem here is if we want to run a solo validator, which is what we're trying to do now, Smartnode is really configured for running Rocketpool mini pools. Now, mini pools are somewhat different from solo validators. There's some nuances to how they work. So we can't really run the validator client within the Smartnode because of some of the things that the Smartnode does with what's called a fee distributor. So the account that gets the fees when we do things like propose blocks. Now, there probably is a way for us to configure the validator client to change the fee distributor. There are ways to do that, but every time we upgrade and things like that, it may get a little funky. So in order to get around that, what we're going to do is we're actually not going to use the validator client in Smartnode. We're going to use the consensus client and execution client in Smartnode, but we're going to use the validator client from a different project. And there's another open source project called eth-docker, and eth-docker is by the eth-staker community and super awesome project. So this project is going to be eth-docker. Now again, it's using Docker technology to be able to package up our client software. And this is basically what our stack is going to look like. We're going to have our consensus client and execution client running within Smartnode, and then we're going to have our validator client running within eth-docker. And now eth-docker has the capability for us, has a couple of commands, convenience commands for us to be able to import our validator keys so that we can actually start performing our duties as a validator. So eth-docker has some great docs. Smartnode and the Rocketpool community has some great docs as well. So we could go through these docs. There's actually a page here within the support section on eth-docker, integration with Rocketpool. Shout out to Patches in the Rocketpool Discord for pointing me in this direction. So this is pretty straightforward in terms of how to configure this. What we want to do is we want to just run the validator. Now, eth-docker does have the capability to run all of the components. So you could configure this just using eth-docker. You don't have to use Smartnode. You could just use eth-docker. You could even get crazy and just run the individual clients yourself. But this makes it a bit more convenient and easier to manage. So before we do any of this, there's one critical piece, and this is where a little bit of Docker magic comes into play. Now, I'm going to go ahead and jump over to my validator here. So I'm on my test server here. I'm just going to zoom in a little bit. Okay, we see that all right. Excellent. So if I do a Docker PS, this is going to show you all the containers that we're running. And we are currently running the Rocketpool Smartnode. And you'll see this is like looking at this picture, but in kind of a listing way of all the containers that are running. And each container has their respective pieces of software. So you can see here, we're running the Nethermind client for our execution client, and we're running Lighthouse for our consensus client. Now, you may notice here that we have two Lighthouse pieces running. Now, a lot of, I think all of the beacon chain clients can run in a validator mode or the actual the chain, right? So it could be downloading and keeping up with the chain. So you can see here that this is the Rocketpool validator, and then this is the ETH2 node. Now, we don't actually want to run the Rocketpool validator that's part of Rocketpool. We want to turn that off. So how are we going to do that? So there is a feature in Docker Compose that it may be just, I think it's Docker Compose. Docker Compose that lets us put in different profiles. So we can associate a profile to this validator that we actually do not use. So when we turn on the default profile, which is what this uses by default, it will not start the Rocketpool validator. So before we do anything with eth-docker, let's go ahead and turn this validator off. Now, Rocketpool, when you install it, there's a directory in your home directory, .rocketpool. You go into that. There's a bunch of different YAML files that you can configure. Now, this is basically a Docker Compose project. It has a bunch of different Docker Compose YAML that you can configure each container that is comprised of the system. So if we go into override, this is where we can apply some overrides. And this will not blow out as you update the software in most cases, maybe in some releases. But this is where we can edit stuff. So what we want to do is we want to actually go into the validator. I'm going to go ahead and edit the validator.yaml file. And this is where we can configure our profile. So under this validator, I'm going to go ahead and let's go ahead and add a line here. And under this validator key, we can add profiles. Is it profile? Yeah, it's profiles. And this is just a little array of profiles. And I'm going to call this profile not active. Okay, so I'm just basically tagging the Rocketpool validator as not active. So I'm going to go ahead and right click that. Now if I go to and I type Rocketpool service start, we should see that the validator actually doesn't start up. So now if we do a Docker PS, it is still running. Why is it still running? We may have to stop the service altogether. Okay, so you wanna stop Rocketpool before you edit this override, because if you don't, then it's not gonna even stop the validator. So what we'll do is we're gonna say Rocketpool service start, and this will start everything back up. The validator is already running, and now we'll say Rocketpool service stop. That's going to stop everything. Okay, so there we go. Now we can go ahead and go into our validator and say profiles not active. Now when we go Rocketpool service start, we should not see Docker pool? What's Docker PS. There we go. We do not see the validator running. So now we're running the entire Rocketpool stack, but we don't have the validator. So we should be in good shape here. But now we need to actually run our validator. Now to do that, we're going to use the eth-docker project with just the validator client. So if we take a look at the docs here, it goes into exactly how to do this. So what we're going to do is we're going to basically type eth-config within the eth-docker directory. Now I already went ahead and cloned down eth-docker. So I have the project here, and you could just pass this command on the command line, and that'll go ahead and clone it down, and it will change your directory right into the directory that I'm in right now. Now this has a bunch of different utilities in it, has eth-do and all the different clients, pretty cool stuff. Now if I go ahead and type eth-config, this should take us into a little configuration screen. Now we are running this on Gorelli. Now we don't want to run everything. We just want to run the validator client only to integrate with Rocketpool. Awesome. Okay. And we're going to go ahead and run the Lighthouse validator client. And what is the URL for your remote consensus client? Now, being that this is running within the Docker network, we could say, all right, it's just eth2 and 5052 is the port that we're running this on. So that should be correct. Now it's going to ask you for where your transaction reward should go. Now I've already got this filled out. This is going to go to the address that I want the various ETH1 or execution client rewards, like your block proposals, MEV, and things like that, should be going to this address. So this is the address that Rocketpool modifies in the Smartnode stack because of the way that funds need to be distributed across our ETH holders and node operators. So I'm going to keep it this way. Okay. And we could put some graffiti in there. So I'll put LIBC, or maybe I'll put li blockchain.xyz. Okay. Excellent. All right, so now we've configured our validator. Now what we could do is we could just basically put it up, but what we need to do is we need to actually import our keys. So this is a critical part. This is a critical part. So we generated our keys earlier in this video. We went through Launchpad and we used the deposit CLI tool from the Ethereum Foundation to generate our validator keys. And then we performed our deposit, and our deposit went through, and now we have a validator that's losing money for us. We've already missed 31 attestations. So let's get this bad boy up. So we should have everything running now to be able to do this. So what we need to do here is we need to basically do this right here. So we're gonna copy the key store files into our validator keys in this eth directory within the eth-docker directory. So let's do that. So if we go out here, and I have the keys within this directory, I believe, right? Validator keys. Yeah. So this file here, this key store, is what we want to import into the actual eth-docker instance. So I'm going to go ahead and just grab this path here. And let's go into eth-docker.eth. So this is the directory that we want to import our keys. And does it go into validator keys? So let's go into validator keys. And I do have a couple of keys in here I was experimenting before. These are all exited already. So I'm going to go ahead and import new keys. So let's go ahead and copy from this directory key store to here. And now we should have this 8323. This key store is now in the proper directory for us to do our thing. So now we're not done yet. Now we need to, I'm just going to go out here, go here. This is where all our commands are. And now we're going to have to turn on the validator and then import the keys. And then we should be able to list the keys to see them. So let's go ahead and turn the validator on. So we do eth-d up. Our validator is now running. If we do a docker ps, we should see that bad boy. There it is. It's been up for 4 seconds. It is running. Okay, so one thing that you want to make sure of is you want to make sure that that port that we specified is actually available and connect. So to be connected to. So we can go ahead and check the logs on the validator using this command. And if we look at it, we can see unable to connect to beacon node. There's one and there's none available. So request is not working here. So it's trying to get eth2 on the 5052 port and it's not working. So what do we have to do here? So let's go ahead and let's go into Rocketpool service config. First thing we want to make sure of is whether or not we have everything exposed, which it looks like we do. And it was 5052, right? 5052. E2 5052. Getting a DNS error. So that's telling me that it's not on the right Docker network. So let's take a look at this. I'm going to say Docker inspect. And we're going to take a look at, so it's going to Rocketpool 2 net. That is not correct. Because if we look at everything else, like let's look at our eth2 client. This is on Rocketpool net. So they're on 2 different networks. That is our problem. So we need to make sure that eth-docker is on the right Docker network. Now, how do we do that? So let's see. Okay, so there's this file here, and we need to edit this. Do that. Okay, so let's go ahead and import these keys. Now to do that, we're going to say eth-d keys import. All right, so it's gonna, this is super important. So what it's going to do is it's going to say, hey, make sure that you're not running these keys elsewhere, because if you are, you're going to get slashed. So you want to make sure that these validator keys that we're importing are not running anywhere else. We're going to go ahead and say yes. Do the validator keys all have the same password? You know what? I probably want to remove the old ones because I'm going to say yes here. This is probably going to fail on a couple of them. Okay, good. So that's fine. So we went ahead and imported the one key. Now let's go ahead and look at the logs. So if we look at the, we could use this command right here. And boom, we are connected to the beacon chain. All validators are active. Total validators are 1. And we are doing our thing. So after a couple of minutes, we should see that our validator here on beacon chain becomes active. I think this is refreshed about every 5 minutes or so. So I will pause this and then we'll come back to this. But we should be live now. Everything should be working. So if we do another Docker PS here, you see that we are running our validator. We're running ETH1. We're running ETH2. There's a couple other components here that make up this, but those are really the core components that we've outlined here. Okay. Here we are live. Our validator is doing its thing. So we now have an active validator. It is running. We can see that we have a couple of attestations that we're hitting, and we're just going to let this cook now. So we are ready to go. Everything is working as expected. So we just went through the whole process. We went through the process of creating our deposit, creating our validator keys, executing our deposit, taking our validator keys and importing it into the entire stack of software that we need to be running in order to actually run a validator. And during that process, we went through and just kind of reviewed gave you an overview of the different components that are at play here to be able to run a validator. So I'm going to let this run for a couple of days, and then we're going to go ahead and exit it. So I'll just end on this. I'm trying to, make this is going to be a longer video, obviously. It's not going to be a series. I'll tag this appropriately. But just to close the loop here, when we want to actually exit this validator, so we want to get our deposit back, what we can do is we can pass a voluntary exit command to the chain. So in order to do that, it depends on the client that you're using within eth-docker, and they have some documentation here. We are using Lighthouse, so all we would do to exit this validator is to go ahead and pass this command here, which is the validator exit command, and that'll go ahead and broadcast the validator exit message to the network, and that will then exit this validator. It would go into an exited state, and then the balance of the deposit would get distributed back to our withdrawal address. Also, as this starts to accumulate rewards, what happens is there is a skimming process. So on the live network today, it's about every 6 days we're seeing withdrawals get executed, and these withdrawals will basically take the accumulated rewards in ETH that are on the beacon chain and transfer them over to your ETH1 withdrawal wallet. So that withdrawal address is going to have this trickle of new ETH being sent to the wallet. That's kind of a nice passive reward flow going on there. So that's the process. I hope this came out all right. If you have any questions, please leave a comment below. If you have any recommendations for new content, if you want help doing this, Long Island Blockchain, my company, is helping folks set these systems up so that you can go ahead and run your own validators. And yeah, I'll see you later. Thanks.